Hello students. At the end of the last video I said we were going to show you next how to find the size of a missing angle or an unknown angle, but I think before we do that let's just have a look at a couple of practical problems involving trigonometry. So here we have a photograph of a slippery slide. You know that the distance from the top of the slide, the horizontal distance, is from the top of the slide to the end of the slide is 4 meters. And somebody's gotten down on the ground and measured this angle here and found out that it's 31 degrees. And the question is, how tall is the slide? Well, the first thing I always do with questions like this is I redraw the diagram. I draw what's called the mathematical diagram, and that basically is the diagram that only shows the information that we need to solve the problem. So there's the right angle triangle. That length is 4. That angle in there is 31 degrees, and we're trying to find the height. Okay, now we can just go ahead and do what we did before. We'll start by identifying the different sides. So opposite the right angle, the side opposite the known angle, and the side next to the known angle. In fact, I think I'll keep this color. Okay, let's go ahead and figure out which trig ratio to use. Well, the side that I know is the adjacent. The side I'm trying to find is the opposite, and the trig ratio, opposite over adjacent, is tangent. So we just start by writing the formula for tangent. Next step is to substitute. So the angle is 31 degrees. The opposite side is the unknown, h, and the adjacent side is 4. Okay, we're now going to multiply both sides by 4, giving us h equals 4 tan 31. And now we just have to finish it off by using our trusty calculator. 4 times tan 31. And 2 decimal places, 2.403, so 2.40. And we're measuring in meters. So the height of the slippery slide is 2.4 meters. Okay, try this one, please. So read the question carefully, redraw or draw the mathematical diagram, and then use trigonometry to find out the unknown length. Okay, let's go ahead and have a go at this one. So first off, let's read the question. Rectangular gate has diagonal wooden supports that make an angle of 18 degrees to the horizontal section of the frame. If the gate is 2.35 meters high, how long would one of the diagonal supports have to be? Rounded off to 2 decimal places. Okay, so let's just go ahead and just draw one of the 2 triangles. I'll go ahead and draw that one. Doesn't matter which right angle triangle I draw. Okay, let's mark in everything that we know. Well, we know that angle up there is 18 degrees. We know that length, so therefore that length is 2.35 meters. And the side we're trying to find is the length of the diagonal. So I'll just call that D for diagonal. Okay, so now we basically turned the word problem into a mathematical diagram. Okay, let's go ahead and use trigonometry to solve this. Okay, the side opposite the right angle is the hypotenuse. The side opposite the angle we know, 2.35, is the opposite, and the other side's the adjacent. Okay, we know the opposite side. We're trying to find the hypotenuse, and opposite over hypotenuse, that's the sine ratio. So let's write down the formula, excuse me, for the sine ratio, opposite over hypotenuse. Substituting everything that we know, sine of 18 degrees equals 2.35 over d. Well, the d's in the bottom of a fraction, so we have to use the old swapperoo. D equals 2.35 over sine of 18 degrees. And we finish off by using our calculator to get the answer. So 2.35 divide sine 18. And we get 7.604. The two decimal places, 7.60. And we're working in meters. So to summarize this video, these are word problems that require trigonometry. So step one, obviously read the question carefully. You might want to underline, try that a bit more neatly. You might want to underline the important information, underline or circle the question, work out what accuracy you need, and then draw the mathematical diagram from that. And once you've got the mathematical diagram, it should be just doing what you've learned previously. Okay, so try some word problems from your textbook now, please.